Please give a huge round of applause to John Carmack. Good luck. Thank you.
All right, it is really great to be here this year. It's been so many years where we talk about what we're working on, what we're doing, what we're thinking about, and actually have it now where you can go over and play Rage, what we've spent 6 years working on. And if you've seen me, I've been spending a lot of time over there just watching people play, generally with a big old grin on my face, where we had so much that we set out to do on this that was different than what we had done before. I mean, it had been almost a stereotype of what you do, first-person shooter, run-and-gun corridors, monsters jumping out at you, this type of thing that we invented this genre, and we followed it for a long ways, but people thought that was that was all that we were doing. And with Rage, we set out to be really pretty ambitious, to do a lot of things that we had never done before. And in hindsight, knowing that it took 6 years, we would look back and say, maybe we shouldn't have been quite as ambitious. Maybe we should have, done a few more of the things that we already had plenty of experience doing. But in the end, everybody gets the benefit of, we picked hard battles, we fought through all of them, and in the end, I think we did a really damn good job on it. Where the things that we set out to do, thanks. And it's kind of a tough situation here where we've got thousands of people here, and we've got a couple dozen stations that people can play on over there. On the one hand, I would like everybody to get a taste of the game, to sit down and just jump in and see how it feels, kind of experience the high frame rate and the smooth interactions and all this stuff. But I also want to see the game is so much more than the sum of its parts, where every level is fun. You can jump on, I think they've got the dev menus there, you can pick any level, jump into it, and kind of blast your way through it and have a good time. But you really don't get the sense of what the game's about unless you sit down and really spend hours with it. And it was great this last press set of things that we did a couple weeks ago where we had them sit down for 3 hours, and you start the game, you play for 3 hours, and you're really only breaking into sort of the meat of the game by that point. You've been introduced to the things that are there, the stuff that you can do, and you're finally opening up. That's the point where the world opens up to you and you can see all of these other things that you can do. And it was, it's great to find these places where you've got people where like, okay, time to go, you need to be leaving. Like, 1 minute, staying on the game. So I'm hoping that a few people will basically camp some of the stations over there and run your way through the whole game, tag team through it, and see all the awesome stuff in there. Where like the new trailer shows a bunch of things that you really only get to on the second DVD, sort of the second half of the game, and there's so much there. It really is probably the most enjoyable id game from my perspective that we've ever made. I've played all of our games to degrees, but I was never one of the people that could spend 8 hours like deathmatching. I know there's a lot of you out there, but that was never kind of like my take on our games. But the pacing on Rage allows us to go ahead and have a game where you have moments of abject terror and intensity, and it's nicely balanced by the areas where you're going through, you're exploring, or you're talking in town, doing these things. And we learned a lot through this process. And by no means are we ready to be stood up next to Skyrim or something as an adventure game, and that's not what we're doing. But it is clear at this point that there are beneficial things that we can add to the gameplay experience, where we take everything that was fun and good about classic id games, and you can do these other things that add additional layers to it, that don't take anything away. There are a lot of design choices where you have to make fundamental decisions. Are you this type of game, or are you this type of game? If you do this, you're going to annoy some of these other people. But there are also some things that are just pure wins, where you can add this on, people can ignore it, or they can go ahead and dive into it and get a lot more out of it. There are lots of aspects to the game that I have to caution myself when I do this, because I'm tempted to go all post-mortem on the game at this point and say, look over, as an engineer, I'm like, oh, this could have been better, we should have done this way, we can make this so much better, we can improve this in the future. But in the end, we hit everything we really set out to do with the game. It took a lot longer than we expected, but everything that we kind of envisioned pretty much made it into the game. And from my point of view, the game has so many things in it that I certainly didn't imagine when we started off, or even early, even 3 years ago. And that's always the most rewarding part as a technical director for me, is I have an idea of what the platform that we're creating will let people do. But when the artists and the designers get in and they build some of these just magnificent things, it's in many ways as much of a shock to me as it is to everybody else playing the game. I don't have that resolution of imagination that the artists can do, where they can build these worlds that are just so fabulous. And the game, when I'm playing the game, you can be into the game, having such a great time, running through it, blasting at things, but practically anywhere you can stop, look around, and just soak in that the world, one of the press people called it a moving painting, and I really like that, where you can stop and see, and how the artists and the stampers, practically every area. It's not just the showpiece room that you make the screenshot for the back of the box, but we have terabytes of data that are just gone through, plastered with all this tender, loving care throughout the game, and there's some really fabulously beautiful areas in it that are really rewarding to look at. And the core technical decision that's gone into all of this, and I always hesitate to make too much of this because people like to latch onto it, but the Megatexture technology is the signature thing that people latch onto as the differentiation. But it's important to realize that is, it's maybe 10% of the code, which is maybe 25% of the effort that goes into the game. So it's this tiny, tiny part, but it is the thing that makes the game stand out, where it gives it its super high performance on the console generation of hardware, and it gives it the kind of painterly look at things. But I will spend some time going over some of the details and the trade-offs on there, because we had to make conscious choices on that. It got us what we wanted in the end. It got us this moving painting at 60 frames per second with this evocative art style through everything. But we did have to make some significant sacrifices and overcome a lot of challenges to actually make that happen. Sometimes I look at it and say, it's clearly the most sophisticated part of the code. Again, there's millions of lines of code in the software code base now, and only tens of thousands of them are sort of directly related to this, but it is dismayingly complicated in many ways, all the things that we had to go through to make this vision of this painted world happen. After this, you'll all be Megatexture experts, and you can point out the flaws and details of this when you're looking at the games. But there's performance characteristics that impact the game. The versions that are playing over there are either PC or 360 installed to the hard drive. So this is sort of the good case performance for streaming in all of the data. There's a spectrum of behavior that you can expect, where the worst behavior that you'll get is if you take a DVD on a 360 without any hard drive, which means that every texture that you pull in has to come in off of the DVD. We do a bunch of smart stuff to go ahead and know where all the textures are, schedule all the reads, batch them up, try and read linearly, but the bottom line is still that you want a new piece of texture data on there, and it can take 150 milliseconds in a bad case or something to go pull that in. And the screen might be made up of 1,000 different little pieces. So in the worst case, it can take 15 seconds for every last little bit of detail to come in. And I know we're going to get dinged some by that. There are going to be people that that run up, and if you want the recipe to make it look as bad as possible, it's kind of back your way into something with a high sensitivity, walk around backwards through town, then flip around and look at something that you haven't had any chance to do, and it'll come in, it'll be blurry, and it'll come in, work its way in, and that's just the reality of the way the technology works that we have to deal with. But we do an awful lot of work to try and make this not an issue, and the great thing is that when you sit back and you watch, I'm having a great time over there looking at a dozen screens playing Rage, and you look at it and it looks great. And I catch myself doing this even at the office, where I'm sitting at my desk with Visual Studio on one side and the game on the other, and I'm looking at something and twiddling the controller, and I'm thinking to myself, oh, this looks awful. Can't we do better at making something here, getting this in better, scheduling this, putting some hint in on that? And I can, like any good engineer, I can almost depress myself about how much more we can do to make things better in the future. But then when I look at people playing the game, just even in the office, running around doing the testing duties or whatever, I'm back to, okay, that looks great. I'm really thrilled to see it running that good, see it behaving that way. And it's always a set of trade-offs in engineering, where we made these conscious decisions that we would live with some degree of textures coming in to give us this painterly world. We would give up on completely general purpose dynamic lighting. Okay. Bug in the mic. We have a report of a bug in the microphone system, so we'll see if this is better. So aside from the raw nature of it as far as bringing the textures in these little pieces, the code that does this is certainly the most intertwined, sophisticated, and highly optimized code in the engine, where there's actually up to 4 levels of locality for how these textures come in. At the closest level to the hardware, everything is broken up into these little blocks of textures. Instead of being one wall that's 2,000 by 1,000 and a coffee cup that's 128 by 128, everything is uniformly divided up into pages of textures, 128 by 128 blocks. And it's interesting how this has gone from 5 years ago when I first sort of did this technology. Originally, I did something for splash damage for enemy territory, and then I generalized it for our early work in Rage. We ran the numbers and we looked at it and said, well, okay, this current generation of hardware, you can have textures that are 4,096 by 4,096. So we break that up into 1,000, 128 by 128 pages, and that should be able to cover everything that we want to do, where you've got about 1 million pixels on the screen and 16 million pixels there. 16x should be sufficient margin for us. And in the early things that we did, like the many years ago demos of the Dusty 8 racetrack where you run around in this reasonably confined area, all that was working quite well. It seemed that we had the numbers, it was going pretty quickly, all the data sets seemed to fit, and it looked like the technology was going to settle down reasonably quickly. We had sets of optimizations that we had to do, but one of the somewhat fateful things that happened a little bit after that, and Tim and Matt still ribbed me a little bit about this, where the artists started designing things that weren't these sort of big deformed facades, which is the most comfortable thing for the technology. Like if you want this Megatexture stuff to work great, work efficiently, you take sort of a big sheet and push it around something so that you've got one, we call it a texture island, one contiguous area of textures on there. And it's super efficient at doing that. It works really well, runs extremely fast. But the artists started building some really impressive scenes using different construction techniques, where they would build all these little modular Lego pieces and throw them together. And then instead of having this great big sort of terrain mesh of things built up into building facades, we have thousands and thousands of disconnected little pieces of textures. And we're like, okay, we can deal with this. We'll lay them all out, crunch them together, and see what we get out of this. And it was starting to look a lot more challenging. And the designers were beginning to say, well, we need some guidelines and some limits. What can we do? Tell us what our guidelines are. And as a programmer, that's always a really hard thing to have a designer come up and say, because the answer is it's really complicated. You can have a lot of triangles here if you don't have a lot of dynamics, and you can trade off like your overdraw with your particles against your texture load here. If you flatten all of this out, you can have a ton of triangles. And I would go on like this, and then everybody's like, give us a number. And I hemmed and hawed, and I really made a really bad call, and I said, well, I want to be pushed a little bit, so go make really cool stuff, and we'll figure it out. And and in the end, we pretty much did, but there is a whole lot of hard work buried in making all of that stuff actually work. To get back to the kind of layers of complexity on all of this. So at the top level, we've got this 4K by 4K page of textures, all broken up into little blocks. And those are all puzzle piece fit around on the screen. And PC guys will be able to, you'll be able to bring down the console and turn on all the little debug tools and peek at how these textures are actually broken up. It pains me a lot that Microsoft and Sony completely disallow the ability to plug in a keyboard and tweak with things. It's even a pain for us in development that our full retail builds we can't bring down and play with debug tools. And I think that's unfortunate and to not any particularly good benefit. But as it is, only PC people get to tweak around with that stuff. But so on, yeah. Yeah, I'll get. So at its best, the areas like 5 years ago I was thinking things would turn out. If you're in the wasteland and you're in a canyon and it's, you've got the cool sunlit stuff up there, if you look at it, you can kind of look around and say, okay, I've got this wall here, I've got my 80-degree field of view, I can look around, and pretty much your entire view, you could turn 360 degrees, and all of that fits in that sort of 4K by 4K set of pages. So once they're loaded in, you flip around and everything looks great all the time. It runs into more problems when you get into these really sophisticated scenes where the thing that hurts us, if you've got the floor underneath you, you can clearly see this is broken up. Okay, 128 pixels, this block here, this takes up this much memory, everything's great. What's a problem is when you look at this awesome set piece over there and you've got all these tiny little things where there's no page, the minimum page size is this block of 128 by 128 pixels. If you've got a railing that occupies 1 pixel on the screen, you may still need a full page wrapped around that, even if you're only seeing one slice of it. We do our best to go ahead and pack things in nearby and and try to minimize complete wastage like that, but it also gives us some false sharing and limits what we can do with anisotropic filtering and all of these things. So the bottom line is it turns out that this single 4K by 4K page wasn't nearly enough. And on the PC, you just crank it up and you say, well, I'm going to use 8K by 8K pages because all the video cards are, have plenty of memory now, and that's what you do. And we built a lot of the game like that. And then when we're like, okay, now it needs to actually work on the 360 and the PS3, and people start looking, it's like, oh, this is like, it's half the detail that it was on the PC. This is missing MIP levels and all that. And we go through this process of saying, well, the 360 can actually support an 8K by 8K texture. We wouldn't really have enough RAM to do that, but if I was left to my own on that, we'd allocate that space and then overlay other things in the parts of the texture we're not using. All that great stuff you can't do on PCs because you're at too much of a distance from the hardware. But the PS3 doesn't even have that capability at all. So you're stuck with these odd notions of, well, do we try and put them in a cube map so we can have 6 sides, maybe a 6-side 2K by 2K, but the addressing on that would be a huge pain. Do we try using a 3D texture with multiple slices, but then the performance goes to hell on there. And we wound up with multiple independent images where we start off with this wonderful, beautiful, elegant virtualized system. Everything flows into all of this, multiple pages, and it's nice and clean and sounds good. And we wind up with 3 different page images of different sizes and different depth complexities, and some of them have just 1 DXT image, some of them have 3, and the virtual materials and the dynamic things are handled separately. So all of this complexity comes in when you go from kind of the initial cool, elegant demo of something to getting it through, delivering what your artists and designers want, and getting it out onto a shipping project. So lots and lots of work went into doing that, about making this thing that originally really was not that complicated. The initial, it was only a small number of days to do the first sort of virtualization of texturing, and a few weeks to a few months to get something where, like, okay, look, this level's running with virtual textures, it doesn't load anything at the start, but it's taken years and years to get to the point where we have all the capabilities that we really want. So here we are at the point with all these broken up little texture blocks on there. If we loaded them directly from the DVD or even the hard drive at that point, you would have a significant lag. You'd be going around, every time you turned a little bit, it would have to bring in a whole row of pages, and that doesn't work particularly well. We started off on the PC with that, where if you have a ton of memory and you look at everything once, after you've gone through it, it stays sort of in your buffer cache, and that's not too terribly bad. But on the consoles, we had to manage everything ourselves. So we have our own second layer cache that sucks up pretty much all the available memory in the consoles, where we load in the stuff that we need, and then every bit of extra memory is available for caching this. We wound up also using that for audio caching. So if something's present in there, if you've got lots of memory, then it comes back in super fast. It has to go through the transcode pipeline, but a lot of the instance maps, if you're playing things that aren't the wasteland, we've got quite a bit of memory that fills it up, and once you've sort of looked at something, it stays in there resident and comes in really quickly. But the Wasteland was our real push case on here, where it was hard to just get that to fit at all on the consoles, and we don't have nearly as much stream file cache as we would like. And this is an area where the PS3 has a good bit less memory available than the 360 because it's got a split memory space where instead of saying, well, you use as much textures as you want and the rest of it's available for other things, you say half of it is available for graphics and half of it is available for CPU stuff, which turns out not to be that bad for us because we almost completely, on our high memory case, maxed that out. So it didn't hurt too much. But their operating system takes a good chunk of extra memory that we wish that we could use for stream file cache on there. But still, once you've got everything in memory, that works pretty good. But if you're coming straight from the hard drive, then the first time you walk into everything, or from the DVD, worst case, or Blu-ray, even worse in terms of total latency time, you're stuck with this very long, have to go. It's the epitome of the physical action going on in here, where so much of this is just ethereal software shoving things around, but you listen to that Blu-ray churning around as it seeks around, pulling everything in. Like, it'll be nice when we don't have that little physical element that we have to be scheduling for and working around. So to avoid the worst cases in that, we added another level of caching where we have a hard drive backing cache, where the first time you look at something, it takes the long trip in from the DVD or the Blu-ray, then it gets written back out to a fast area on the hard drive, so we can bring it back in the next time from the hard drive instead of from the DVD. So it's sitting in the stream file cache, then eventually it gets transcoded and put onto the actual texture that the GPU touches, that then puts it onto the screen. So 4 levels of locality there before it gets to the screen: optical media, hard drive backing cache, stream file cache, texture. And it gets yet more complicated by the fact that on systems that do have a hard drive, on the PS3 and in particular, we get to install some of our textures to the hard drive. On the 360, we don't have a partial install option. It's all or nothing, which is kind of unfortunate, which means you have to install 21, 22 gigs of stuff, which takes a long time. But if you've got it and you're going to play it on a 360, that's the way to go. It makes a significant difference. Everything comes in without having to hit optical media. On the PS3, we install some of the important things on there, and we're still negotiating with Sony on exactly how much space that we can take. So Bethesda's kind of trying to twist arms to say, it's like, well, you can give us a couple more gigs because we'll be able to then stick this other page file on here, and that'll be, that'll make that part of the experience that much better. To start touching on one of the, if only we had a little bit more time or had worked on it earlier, the better solution for that would have been to split our page files and say, okay, all of the low detail stuff goes onto the hard drive cache, and then all the high detail stuff stays on the Blu-ray, possibly backed by the temporary hard drive cache, because then you would never have the grotesquely ugly cases where you just like, oh, what is that blurry mess for a quarter second that you can get when it's coming straight from optical media. But that's, again, it's the most sophisticated code in there, and to some degree we cringe a little bit every time we try to implement some new feature in there, because it's at the heart of the most asynchronous threads, all the different devices. There's one thread that's dealing with reading from the DVD, one thread reading from the hard drive. There's additional threads doing the analysis of the feedback buffer to figure out what it needs to do. And then there's a bunch of threads doing the transcoding where it comes in. If we had infinite space, we would have just stored everything out directly as it was going to go into the texture. That would have been great. You could do an unbuffered read directly off of the file, directly into the texture, and the GPU could be using it immediately. But unfortunately, that would have meant that the game would have been either less than half the current size, or you don't want a deck of 8 DVDs to play a game there, and that's sort of the data set that we would be looking at there. So we have on distribution media, everything is compressed using an HD photo derivative on there, and Microsoft gave us a license to use stuff derived from their code base for that, which was a really good thing on there. We had our own DCT-based version, but it just was this significant 30% or more not as good as what we could get from there. So 30% of the quality that we were able to pack onto the existing disks is due to having a more sophisticated encoding method. But of course, that also means it takes twice the processing power to do that. So we have all this work where we bring this in, comes in this HD photo derivative, gets sent out to a whole bunch of threads, decompressed to a YCOCG color space on there, but then we have to recompress it and re-encode it to DXT for the actual video cards on there. And that's one of the things there's a number of things that we may get to do on future PC releases for potential higher quality. I'm hoping that the PC version will street the same time the other versions, but because it's a Steam release on that, we get to work on the PC version longer, so we're hoping to get a good bit more tuning in on that before we finally get it out. And it is extremely frustrating knowing that the hardware that we've got on the PC is often 10 times as powerful as the consoles, but it's honestly been a struggle in many cases to get the game running 60 frames per second on the PC like it does on a 360. A lot of it's driver overhead issues where there's so much that we do in the game that all of this dynamic texture updating, where on the console we say, all right, we've got a new page of data, we put that page in there, and then we update the page table that points to that. And on the console, that may just be a matter of writing an int to a memory. It's like, here's the texture, let's calculate exactly where this part of the page table is, and then we just poke it right in there. On the PC, that turns into potentially a text sub-image 2D. And if you're a programmer and you start single-stepping through that, you'll cry. You won't make it back out. It'll just take forever that'll be going in there. And that's where we're looking at that on the console. We put the memory in there. That's what it is, that's where it goes, and we stick it there. And there's reasons why PCs are like that. They have to work with very different memory architectures. The tiling and swizzling formats are different between them. But we may be seeing some light at the end of that tunnel where there have been enough kind of hints from the relevant vendors that maybe it is time to start standardizing on some in-memory footprint and formats so that PCs can be a little bit more efficient at some of this. And especially we're leaning on Intel, where Intel's current graphics hardware is getting decent. It's not going to, it's not going to be this is the embedded hardware that everybody has just dismissed. You've forgotten you had it in your systems because you went out and you bought a serious, NVIDIA or AMD video card on there. But it's been there for running people's Word apps and whatever for a long time. But each generation, it gets better. And at the current generation, we have Rage running on the Intel hardware now. It's not 60 frames per second yet, but we're looking at this as it's not, people still laugh when Intel integrated graphics comes up, but it's not going to be long before you are really going to be able to actually use that. And I know that's certainly making the dedicated video card manufacturers a little bit antsy on some level because there's clear trends going on there. But the important aspect from that is because it's an integrated memory part, unified memory, there's no reason that it shouldn't be like a console. It's all in one same set of memory. I should be able to get the address of that texture. I should be able to get the stride and the swizzle format and say, all right, I want my texture update. I'm just going to go push it in there. And we have sort of notional buy-in from Intel that this is a good direction. I mean, old-time graphics people still they cringe at the idea of exposing internal formats. There's a long culture of being able to do things behind people's back that really has led to a lot of grief in the PC graphics industry. The fact that DirectX sort of pretended you could lock a rectangle of an image, but what happened in most cases, behind your back, drivers were like copying the whole texture in and out, re-swizzling it, pretending it was like this for you, and then doing the inverse to put it back into video memory. And that's where it's a leaky abstraction. It's where we're trying to pretend that all these graphics hardware behaves in a certain way when they really don't. And for a lot of things, abstraction's great. You want to be able to step back and say, here, we're doing one thing, we want it to behave just with slightly varying characteristics. But when you're doing really aggressive real-time operations, sometimes those abstractions will really kill you. And it's happened to us over and over again where we take something, it's working fine on the consoles. There are these open questions of, well, do you want to use parameter buffers, texture reads, all these different possible ways that you might go about doing it. And I can look at a hardware reference manual and say, well, it should be able to just DMA fetch the stuff in like this. It should be able to be poked in here. But often they have to go through incredibly convoluted things in the driver to work around that. And there's good reasons why that stuff happens. I mean, one of the things that that I'm to blame for that I regret a lot is there are hacks in all current graphics drivers to identify whether you're playing early versions of Quake, because I did things like when I was getting the extension string, I just had a buffer of like, 1,000 characters should be enough for all the extensions, and we do copy a GL get string into there. And of course, as drivers got to the point where they had tens of thousands of characters of extension strings, that would just stomp all over memory. And they went in behind our backs to our benefit and said, well, if we identify that you're playing this game, we're just not going to do this. We'll do this other thing. We'll give you a shortened list that fits what you're expecting. So there's archaeological reasons why PC drivers have a lot of the stuff that they do, but it is very unfortunate that they have to rely on such an overwhelming amount of brute force to overcome the console's low-level advantage there. But again, there's signs that things may be getting a little bit better there. I'm hoping that we will have, to speak to another success point on here, it is kind of nice only having sort of 3 relevant graphics vendors to work with on this. In the old days, in the Quake 3 time frame, there were 20 different people making graphics chips, and we kind of had, we were sort of on top of all of that, but a lot of them should not have been writing graphics drivers. You had a clear separation between the professionals that knew what they were doing and the companies that didn't. And right now, everybody working in the industry at a high level knows what they're doing. They have the intelligent conversations about things, and we can reach agreement on a lot of things. Where we had talking about 60 frames per second swap interval stuff, where what we do on the consoles, and you can probably catch signs of this if you play the games aggressively. We try to be 60 frames per second, swapping exactly with the swap interval all the time, but we monitor a lot of things and we adjust the game's behavior in the rendering side. We resolution scale when it looks like we might be going over 60 frames per second. So we've got all this dynamic resolution scaling going on, but there's still cases where we can't predict that all this, we talked about trying to do some more not so much predictive, but like when explosions go off on there, we should have been able to inform the renderer that that's going on and preemptively scale it down a little bit. That's another one of those things that we should evolve towards a little bit more. But right now it's reactive, where as you're running through the scene and it gets more and more complex or more and more heavy with particle overdraw, it slowly scales the resolution down, and usually you won't even notice. But when something unexpected happens, like something just jumps into view from offside and massive explosions and After Effects go off, we can miss the target frame rate. What we do then is we allow it to go ahead, and instead of having the classic PC problem where either you choose swap interval locked and you get into this ugly, awful stuttering when you're not quite 60 frames per second, you're bobbling between 30 and 60 and it doesn't feel very smooth at all, or you just accept the tear line as kind of the standard in high-speed PC play, which really is one of the more objectionable graphics artifacts that we deal with now. So what we have now is, on the consoles, we proved this out first, where you're locked as long as you're going 60 frames per second, and as soon as you miss 60 frames per second, then you get some tear lines. And hopefully our dynamic adaption and everything catches in, and a couple frames later, the tear line just kind of runs back up to the top of the screen and it stops tearing again. And it was really good that we were able to make the case to NVIDIA and AMD, and I think Intel's even going to address this as well, that, look, this is an important thing. We are obsessing over some relatively unimportant things with sizes of filter kernels and the other things that graphics geeks can go on about forever, but we've got this stupid, ugly tear line going down the screen, or we've got this non-isochronous swap behavior. This is actually an important thing to fix. And NVIDIA went in and put something together pretty quick and defined it's a little bit of a hackish interface where we didn't define anything new. We just said, well, negative swap intervals will mean, swap to this if you can, otherwise tear. And AMD looked it over and said they could do the same thing. And, hooray, a success story for industry vendors cooperating on that. So, that's been actually pretty good. But we're going to push. We've still got time to make some significant pushes on the PC side of things. We do not have any crazy PC-specific features that are going in on the rendering, but there's actually a lot of things in the near term, like initial shipping version of the PC, we need to tune how big we can make the textures, where people that have multi-gigabyte video cards, that 4K by 4K texture on the consoles, we should be able to turn that into a 16K by 16K texture so that, once things are resident in that, you can make quite a bit of moving around without ever actually having to transcode anything else again. And that's stuff that we'll get that tuned up relatively soon. But I'm also looking forward to the possibility of doing some almost research engine-like things that may be able to leverage some of the Rage data. Kind of back to the old days where GLQuake came out, where it was this completely unsupported thing that you just dropped this EX in and ran this, and it kind of showed you what I was playing with technology-wise with the existing data. And I'm thinking that I might be able to do some things like that, possibly with Rage. It is a little bit of a bigger deal considering the size of the company we are and all this, where I'm not positive I can get away with just here's completely unsupported, but play around, it might be kind of neat. It might look stupid in some places. But that's something that I'm thinking about, because there are the far out technologies that I'm looking at, and all the different ways of representing things, whether you want to do tracing and splatting and voxels and non-polygonal stuff, but that's still relatively, that's not what we're working on right now. And I'm interested to see how far we can take our current data sets. If we say, here's what we've got, how good could we make it look by essentially changing the technology? Because we really don't want to reinvent our entire content pipeline again. Because again, it took, the demo of, look, a virtual texture, it's over 5 years ago. It took 5 years to get everything that goes into this for how we create the stuff, how our back-end processing, and how we distribute all of this. It takes a long time to go from demos to production work. And the cold, hard truth is, every game that we've done that's come out of id Software proper on our main line has taken longer than the game before, and that cannot continue. It's always well and good you plot trends and say, look, an exponential curve. There's a whole bunch of areas like this where you can say, well, that means that 3 generations down the line, we'll be taking 30 years to create our next game. But as is always the case, if something can't go on forever, it won't. And it's all a matter of how you do the landing from can't go on forever that determines how you're going to come out of it. You don't want to crash land. You want to go ahead and ramp that off in some way for a nice, smooth, flared landing. So that does have impact on how we look at our technology development going forward. And I've said for years now that I think that we are past the knee of the curve in terms of what we get from graphics technology on there. There's no doubt that graphics still matters. Rage looks spectacular, but we made conscious choices that, okay, it could have looked more spectacular and we could have been a 30 frames per second game like most of the competition, but we decided early on, although it was a hard-fought battle, which at this point, despite all the pain and suffering that we went through, I think everybody's real happy that we did make the call that we did. It did involve a lot of suffering on art design and programming side, but that initial choice to say, we can do fancier graphics. There are techniques that we can apply that will make the game look better, but I'd rather have twice the frame rate. And I think that that question of how we spend our resources, there's a lot of options on there on what we want to do with it. So technology-wise, I'm going to do more research engines. I've got a handful of little things that I'm tinkering with. I've actually, there are still people at the office right now making our cert candidates, but it's mostly of the, like, what do you do when you're at the disk swap and somebody sends you a multiplayer invite and you yank out your memory card? What do you do? So the main game part is done, and I've actually stepped a little bit away, and there's still people there that are there all night working on getting the stuff done, but I actually opened up another little project and started writing some new code relatively recently to start exploring some things, and that's it's nice to be able to start looking at some additional things, but it's possible that some of these research engines might turn into other things to do on the PC with the game. Certainly, We're not going to try and recertify a game with some fancy new rendering technology, but I'm interested in seeing what it looks like if we take the content that we've created now and say you make perfect anti-aliasing or perfect motion blur, or you just really do sort of the speed of light calculation here where you say, if everything was how we wanted it to, and this was the data that you had to work with, what could you get out of it? And it's an open question of how compelling that would be. We do have 10 times the horsepower on the PC that we have on the consoles. If we, and we are using the PC as just a sort of a muscular console in this point. We're not doing anything radically different. There's not DX11 tessellation or anything in there. I don't believe really in bolt-ons like that. I think it's something that you have to design for from the beginning, and we did not choose to go that route on this generation. But if we want to throw these ridiculous amounts of power at it, and it is, it's crazy how much power we have. I spend a lot of time just smiling and being amazed at how much computing horsepower that we have to look at with these. The high-end graphics cards, you've got at least 10 times the power of the console. And I know in previous years I've talked about how we've got this factor of 1,000,000 where I've gone from like the first game that I wrote to what we're doing now, 1,000,000 times more power. But the interesting thing was a month or two ago, we had a case where I actually looked at it and said, this is a factor of 1,000,000,000, where I was spending a little bit of time reading about things that were before my time, like Atari 2600 programming. And the internet is so awesome. You can go and look at program code and ROMs and things that people have written and disassembled of all these ancient systems. And that was the system from when I was a kid. I never programmed for the 2600. I knew a few people that overlapped my development space that that did do some work there. But it was an incredibly primitive machine. You had 128 bytes of RAM and 2K of ROM on the early cartridges. Later with all their fancy bank switching, they got it up to an amazing 16K of ROM on the highest, most expensive cartridges. So it was fun reading about all of this, and it's again one of those things where if I only had a bunch more time, I'd like to go, do a little test app and try out certain things on there, but not likely to happen. But still, you go and look at that and say 128 bytes of RAM. One of the things that we were doing in our production side of things for cranking out our build games to rebuild all the games, when we build our virtual textures for the dynamic stuff, it's this process that at one point it just took hours. I rewrote it to be such a way that it used huge amounts of memory mapped files, and it got down much, much faster, but it really started swapping on any system that we had. So we said, well, let's find out what the actual limitations here are. So we took one of our servers and we put 192 gigabytes of RAM in it. And it's like $5,000. We used to spend more than $5,000 on a desktop PC. We had $10,000 workstations back in the day, but 192 gigabytes of RAM. And I think back, okay, 128 bytes of RAM in the Atari 2600, 192 gigabytes of RAM being used to build this, greater than a factor of 1,000,000,000. Now that's stretching from, before my time to a server grade system here, but it's still, it's 9 orders of magnitude. Where do you see that in anything else? And you also see it on, the storage going from 2K to, 2 terabyte drives are pedestrian. That's another factor of 1,000,000,000 there. So that's, pretty amazing to look at that. And we've got a lot more yet to come. Certainly serial clock speeds have pretty much petered out. We're going to see a little bit more on that. But the massive multi-core performance that we're getting, and certainly all the experience with the GPUs, we're going to be seeing more orders of magnitude coming yet. So the big question is, as game developers, what do we want to do with those? There's some obvious cases where, as we look at throwing things up for high-end PCs or next-gen consoles, there's the immediately clear stuff. You say, well, instead of running at 720p, I'm going to run at my 2.5K by whatever high def PC monitor on there, there's a factor of 3, or start running multiple monitors, take it up to maybe a factor of 10 there. You go ahead and run your 4x or 8 or 16x multi-sample fragment anti-aliasing. You take everything out to much higher dynamic ranges on there. And all of those are the obvious things where you're just cranking knobs that already exist. There are things that are beginning to look possible on this level of hardware where I'm looking at this thinking, I guess we can do a full fast Fourier transform on the entire damn screen and do full screen convolutions of things where instead of having our flares be these sprites and blurred things that we have on there, we can convolve the whole damn screen with this giant starburst and have every little pixel come in right. That might be interesting. That seems like an almost criminal way to spend that many floating point operations for a post-process operation. But if they're there and we don't come up with something more compelling to use them for, it's interesting. There's a lot more that we can do with anti-aliasing and filtering. We can certainly continue cranking up more polygons, more texture density. But we are at some of those points with texture density where another thing that Rage will get knocked for. If you go and you jam your face into a wall, the textures are going to be blurry. We don't have detail maps on top of them. We are, in many cases, at a little bit lower resolution than a game that's just tiling textures would be at. And it would be nice to address that, but it's likely that I'm not expecting anything to supersede Blu-ray in the real near future. The world's moving towards digital distribution in a lot of ways. DVDs are definitely annoying to have to swap DVDs to get what we want on here. Another of the things that I do have to watch myself a little bit on some of these. Like, I'm going to say some things that I know are going to get taken out of context, and I may regret a little bit later. But I wish that we had had the time to max out a double-layer Blu-ray DVD for the PS3. Right now, we deliver the same content across all of it. And realistically, it's not just a matter of saying, we could have just done this. It would have been a lot of effort, and it would have our build process. We're down to the wire as it is. We would have been courting failure if we had tried to do this. But it would have been nice to have twice the data there that we could have pulled out from without our artists having to draw anything different. We could have changed our compression ratios and the way we call the detail out. And that could have offered some better view there. But on the other hand, the Blu-ray is the slowest seeking device, and the PS3 has the least available memory. So it's not completely clear what benefit we might have had off of that. But that's another thing I'd like to do on the PC is I would hope that we could make some kind of DLC that maybe we take one level and we encode it at 10 times the bit rate or something. So like, here's one level, but it's 2 gigs or something rather than the 500 megs or 300 to 500 megs that we make each individual thing, just to see what's the extra benefit. Because I do think that if you're just running around playing the game, like if you watch everybody playing over there in the hall, doesn't make a whole lot of difference. But when you stop and you want to really appreciate it, there would be an extra level of appreciation that we could get there. And so that's another thing that we may try to do on the PC. Higher rate data sets, larger pages that we wind up pulling the stuff into. But it's worth talking a little bit about how we pull all of this data in, where the shipping game, obviously, it fits on one Blu-ray disc. It's 20-something gigs that you wind up putting into everything. But the source data is so much larger than that. The textures that go together to build, that are the source art that go into building the megatextures, we ran into a limit where it ran out of a 256,000 by 256,000 texture where everything was fit into there. And that's all the source art, the mountainsides, the ground, the stamps, and everything that gets built into, or that gets baked into the textures that actually ship. And you look through that, so it's 64,000, so that's 64 gigatexels of source data, and each one is 3 channels or 3 images of 3 or 4 channels on there. It's 12 bytes on there. So with mipmaps, that's a terabyte of source art that goes into making the content that goes and ships on the 1 Blu-ray or 3 DVDs.